some of the things we are going to cover in I will make it simple. Introduction. Do you guys know what is the definitions of complex number and De Moivre's theorem? A complex number is a number that can be expressed in the form a plus bi, where a and b are real numbers, and I is the solution for the equations x2 equal to negative 1, which is called an imaginary number because there is no real number. Teacher, what about De Moivre's theorem? De Moivre's theorem states that for any complex number and integers, it proves that its equations, where I is the imaginary unit. Okay, now I will explain more about this topic with some examples. Here are some operations which include additions, subtractions, multiplication. Okay, let's go to the next slide. This is triangle, and from the triangle we know that cos theta equal to a over r, which is a equal to r cos theta, and also sin theta equal to b over r, which is b equal to r sin theta. Therefore, z equal to a plus bi can be written as z equal to a plus bi in standard form, and z equal to r cos theta plus I sin theta in polar form. That is for the magnitudes of z. Here are some examples on how to express the complex number into polar forms and vice versa. Power and roots of complex numbers. De Moivre's theorem. If z equal to r cos theta plus I sin theta is a complex number and n is any positive integer, then z to the power of n equal to r to the power of n cos n theta plus I sin n theta. De Moivre's theorem can be proved by using mathematical inductions which compose of two steps. This is an example on how to simplify z equal to the power of 8 by De Moivre's theorem. Roots of complex numbers. This is an example on how to find the roots of complex numbers. N's roots of complex number. If z to the power of n is equal a plus bi, then z equal to r to the power 1 over n cos theta plus 2k pi equal over n plus I sin theta plus 2k pi over n, and for k is equal to 0, 1, 2, 3 until n minus 1. This is an example on how to solve the nth roots of z. The number of roots depends on the number of n's. For this example, if n is equal to 4, so the number of roots is 4.
Application of complex number in our day-to-day life. we all know that complex number is that number that cannot be defined in real numbers. We can imagine or we can take some numbers, like we can take 10, or we can even take 15 or 25, or even -1. If we do the square root of every numbers, let's do the square roots of every numbers. Like 10, we have get the real numbers is 1.6 something. If we do the same for our next numbers, like 15, it's also got the real number. If we do it for 25, we have also the real number. But when it comes to the number of -1 of square root, it shows the math error. Actually, there's no value in our calculator, or there's no value in our real numbers of the number of square root of -1. But in our terms of mathematics calculations, like when we do the calculations of any circuit, or when we do the calculation of quantum mechanics, especially the theory of especially when we do the theory of relativity, etc., we need to calculate the value of square root of -1 as well. That's why the scientists put a number. They made it I as the value of square root of -1. So in real life, like actually in our day-to-day life, there's no such application, but especially in quantum mechanics, when we want to calculate the speed or the velocity of air, or we want to calculate the speed of let's see, the light and the air, we need to calculate this I as well. We cannot just demolish this I. Suppose we are calculating any angles, like we have our angle of 360 degree, and again we can calculate our angle into a radian. But when we have when we need to calculate the smaller degrees into radian, we need to put some values which can make it equivalent or almost equivalent to our real numbers. Like if we it sounds so complicated, but in real life, if we look at the sky, it's like a lake, or it's like stuck on something. But in real, it's actually moving. And scientists already discovered that the sky is actually 30 degrees from the sea level. That means we are looking at, suppose we are looking at the sky, and here is me or anyone. We are looking the sky like it's 90 degrees from our point of view. But in a real life experience, or in reality, scientists prove that it's not actually 90 degrees. It's actually 37 degrees. It's a 37 degree from the ground. So what is happening here? Like we are seeing it at 90 degree, but it's in 37 degrees. So the actual thing is, at our vision is seeming like 37 degree plus I something. And here comes the complex number or the imaginary number to make it more efficient or make it more coefficient in a real life examination. And I guess that's all from me about the application of complex number.
Yay! Hooray!